Happy Memorial Day, everybody. Today, we are going to begin reviewing for chapter 16, which is our matrices chapter. I don't have as many things printed for this one, so I'm going to steal a couple ideas for some stuff. I just wanted to kind of make sure I threw some things out here that you'd be used to seeing, and we could kind of go through some examples before you had to take the test. So, if we're looking at something like this, just give you kind of a general idea of a couple problems that were like on the last test that are some things that are going to be fair game for the final. So if I give you something like this, right? Let's go with 2x minus 3, 0, 3 halves, y plus 7, and 0. And I say that that is equal to a 0 matrix that is 4 by 1. Well, here's a couple things that I want to be able to pull from something like this. First off, it's when we're talking about the dimensions of a matrix, that first one is how tall it is or how many rows we have. And that second one is how many columns we have. So this is a 4 by 1 matrix, and it's set equal to a 0 matrix. It's 4 by 1. Now, remind you, 0 matrix means every single element is 0. So if I've got 4 elements here, 2 of them are 0, those are already set. When I'm solving for something like this, what I'm doing is setting up both of those equations and setting them equal to 0 to solve for the two variables that we have. So I would have to do 2x minus 3 equals 0 as one of my equations. We'll solve that real quick. So plus 3, 2x equals 3 divided by 2 divided by 2. X is equal to 3 over 2. Okay, so there gives us one answer. And then we'd set the other one equal to 0 by that 3 halves x, 3 halves y plus 7 is equal to 0. This one's not going to be a fun one, but I mean, it does tell you how to deal with these. We had a couple problems on the last assessment that dealt with fractions that were not anybody's favorite, and I just want to make sure we're on the same page. When we move the number over, just remember, you can divide by 3 halves on both sides, and your calculator will do the work, but for me, I like getting rid of it in 2 steps. I'd get rid of the denominator first, so we'd have 3y is equal to negative 14, and then you can divide both sides by 3, and it's just a little bit of an easier math when we're doing it. I'm not afraid that you guys aren't able to do fractions. I just think that it's something that it's nice to be able to take fractions off in 2 steps rather than in 1. And when you multiply by the denominator, it just cancels out. Okay, so other things that are going to be fair game for dealing with the matrices is going to be finding the determinant of a matrix. So if I'm going to be looking at a matrix here and I'm going to be finding the determinant of that matrix, I'm going to tell you this from a 2 by 2 and then a 3 by 3. So if it's a 2 by 2, and the determinant is when we have these lines on the side here, I'm just going to pick random numbers. So 5, -7, 8, -3. And what you're doing when it's a 2 by 2 matrix is you are taking the diagonals, multiplying them, and subtracting. The first one is top left to bottom right. So we do 5 times -3 minus bottom left to top right, 8 times -7. So this is the determinant. Determinant of a matrix is like one number that represents what's happening with all of it. So here, this will be -15 plus 56, and that will give us a positive 41 as our answer for the determinant of that 2 by 2. Now, when you do stuff like this with a 2 by 2 matrix, super easy. It's just you do those and we're good. That gets involved when we start talking about the inverse of a matrix. But for right now, this just kind of gives us a place to be able to talk about it. The 3 by 3 is the one that takes a little bit more time. And so when we do a 3 by 3 matrix, let's go. I'm going to try to keep the number small because I'm doing a lot of this in my head. So let's go 4, -1, 2, 3, 0, -1, 8, that'll be fine, -2, positive 5. Okay. When we're finding the determinant of a 3 by 3 matrix, the first thing that you're going to be able to do, and guys, I'm not going to make you expand by minors on the test here because it takes a little too long. For this, if you've got the 3 by 3, the easiest thing to do is to copy over those first two, 4, 3, 8, -1, 0, and 2. And then what you're doing is 6 sets of multiplication. You are going to take the first 3 diagonals going upper left to bottom right, and those are going to be our positive ones. So I'll start with those. So when you do this, you're multiplying all 3 numbers together. So 4 times 0 times 5 plus -1 times -1 times 8 plus 2 times 3 times 2. So I'm taking each of the numbers from those and multiplying them together. That gives us our three positives. Now we're going to be doing the three negatives. Those are going to be these three. I tend to go right to left, but it doesn't matter the order you do them. So minus 5 times 3 times -1. That's our first one. Minus -2 times -1 times 4 minus 8 times 0 times 2. That gives us all of our numbers from all of the things, the three minuses in the second half, the three pluses in the first half. Now, I'm going to do the quick multiplication for them, and let's hope that the numbers are easy enough for me to do in my head. 0 plus, these negatives cancel with the 8, so 0 plus 8 plus 12 plus 15 minus 8 minus 0. Okay, so the nice thing about this is the ones with the zeros, they go away quick, but we've only got 6 numbers to put together. 2 zeros don't impact. Positive 8 and the negative 8 cancel each other out. So the 12 and the 15 together is going to give me a 27 as the determinant of that 3 by 3 matrix. Again, it's not hard. It's just a process, and you just kind of have to go through it as you're doing it. That shouldn't take you too long, but it does kind of give you an idea as to what you're supposed to do. Now, we're going to talk a little bit about multiplying matrices, because that was something that I think caused a little bit of strife. I mean, it's not terrible, but it caused a little bit of a problem. So if we're doing this, first thing that you need to know is that if I'm multiplying two matrices, A and B, the part that's going to be the most important is that if I have like a 2 by 3, this one has to start with the second dimension of the first matrix. So it has to start with a 3. And then it has to end, whatever it ends with, that's what the end one is going to be. So let's say that I'm going to make this a 3 by 2. I'm going to try to make this one a little bit simpler. Since these two match up, it allows us to be able to multiply them. And then what we're going to have left is going to have our first one here by our last one here. So our final result is going to be a matrix C, which is a 2 by 2 matrix when we multiply those. Now, I'm going to make these and show you sort of what we're going to do with this. When we do a 2 by 3, it's going to look like this to start. So again, 1, -2, 3, 4, 1, -1. I'm making them small again. And then for this top one, so that's the 2 by 3. Now I need a 3 by 2 that I'm going to multiply it by. And I'm going to go 1, 0, -5, and then 4, 6, and -2. Okay. What ends up happening with something like this is that when you're multiplying them out, you're going to multiply that first row by that first column first. Each of the different individual elements multiply together, and you add the 3 of those as you do it. So it is going to be, I just made the corner here. We'll have 1 times 1, that's this times this, plus -2 times 0, plus 3 times -5. That takes care of this row with this column. Now, I'm going to do it with the same thing. First row with now the second column. So that's going to be 1 times 4 plus -2 times 6 plus 3 times -2. Okay, so that gives us those two answers. I can do that math now. That's going to be 1 plus 0 minus 15. So that is going to be -14 for that element. This will be 4 minus 12, which is going to be -8, minus 6, which is -14 as well. That is a completely random thing because I threw those together. The other two are both -14. I'll be buying a lottery ticket. Okay, so that's those two numbers. Now we're going to be going with the second column with both of those rows as well. So it will be 4 times 1 plus 1 times 0 plus -1 times -5, and 4 times 4 plus 1 times 6 plus -1 times -2. And that'll give us all of our elements from that. So this is going to be 4 plus 0 plus 5, or 9. Looks like no lottery ticket for me. This one is going to be 16 plus 6, which is 22, plus 2, which is 24. So when we multiply these matrices together, our final answer for this is going to be -14, -14, 9, and 24 as our result. And that's what we're going to be looking at for something like this. So multiplying isn't that difficult to do. You just have to show all the work of what you're doing. And we should be good with that. Finding the inverse of a matrix is another thing that you're going to need to be able to do. Finding the inverse of a matrix that's a 2 by 2 is as far as we're going to go, because they get kind of insane if you do too many other things. So what I want to make sure that we have for something like this is I'm going to give you some general things with what we're looking at. We're going to call this matrix A, and this is going to be 4, -3, 2, and -5. Okay, so when we're looking at this, I specifically chose 4 different numbers so you see what happens to each of them. Sometimes they repeat, and that makes them a little bit more difficult. What we do with this first is we take 1 over the determinant of matrix A, which I'll plug in later, and we are going to multiply that fraction times what I'm going to just call a rearrangement of the values on the inside here. We are going to take these two on the diagonal here, the 4 and the -5, and switch them. The -5 goes up here, and the 4 goes down here. Then, with the ones on the other diagonal, we are going to make them the opposites. So that -3 becomes a +3, and that +2 becomes a -2. So this is how we get to being able to get our inverse of matrix A. Probably should have put an equal sign. Okay, so that's going to be our inverse of the matrix. Now, we actually have to go about finding that determinant to be able to work with it. So this will be 1 over 4 times -5 minus 2 times -3. So let's think about that. That'll be -20 plus 6, which is going to be -14. So what I'm doing is -1/14, that'll be a -14, times -5, 3, -2, and 4. Now, some of these are going to reduce, like the ones that are even, but the odd ones are going to stay the same. So when we do it, here's something that did actually, I struggled with a little bit on the test when we were looking at it, is when you multiply these in, don't forget that the negative from the outside does come into the negative on the inside. So when we multiply this first one, -1/14 times -5 is going to give you a positive 5/14 because the two negatives cancel out. And with this one, because the negative goes with the positive there, we'll have -3/14 right there. And then here, the negative cancels out as well. But because it's 2 over 14 and those are both even, that'll reduce to a 1/7. And when the -1/14 multiplies by the 4, we will have a -2/7 at the end. This right here is what we're going to have as our inverse. Now, it's not actually something that I believe that you're going to be asked to do as a part of your work on the final, but if you have an inverse, what you can do with something like that is to multiply it together to be able to get that. If I multiply it with the original matrix, we will end up with what we call the identity matrix, which just has ones down the diagonal and zeros here. That is not something you're going to be asked to do. And in fact, what we've done, I think, is the extent of what you're going to have to see when you do the work on the final with matrices. But I did want to make sure that you had an opportunity to see all of it. And I thought that was probably enough. So I'm going to stop sharing and say, happy studying.